Hello, my name is Mark Lewis. I'm the Vice President of HCU Network America. I'm the proud dad of 3 adult children. My oldest, Ben, is 32. He was diagnosed with classical homocystinuria through the newborn screening program in the state of Massachusetts where we live. My youngest, Gabrielle or Gabby, is 22. Gabby also has classical homocystinuria, and she was actually diagnosed during my wife Karen's pregnancy. I'm excited and honored to be here today with Dr. Harvey Levy, a pioneer in the discovery and development of HCU. Dr. Levy is a senior physician in medicine and genetics at the Boston Children's Hospital and a professor of pediatrics at the Harvard Medical School. Dr. Levy's over 50 years and counting career has brought him through the discovery, treatment, encompassing lab and clinical research, diagnosis, newborn screening, metabolic patient treatment, and ongoing follow-up. Truly a force within the treatment of metabolic diseases and specifically for HCU. So Dr. Levy's interest in HCU dates all the way back to the very beginning of his metabolic journey. He is credited for identifying the first patient diagnosed by newborn screening in the United States and worldwide. Dr. Levy is credited for the co-discovery of the first human vitamin B12 disorder, known today as cobalamin C, in conjunction with the late Dr. Harvey Mudd. Dr. Levy's authored over 500 articles in the metabolic diseases and countless chapters and 2 books on the topic. Dr. Levy is currently principal investigator at the Boston Children's Hospital for the ongoing clinical trial for a promising treatment in HCU. He also serves as a medical advisor to the HCU Network America. He's received numerous awards and citations over his career, including, and not to be remiss, is the recipient of the HCU Hero Award by the HCU Network America. Dr. Levy, thank you for spending time with us today. We're eager to hear your journey through the discovery and accomplishments that you've had in support of our HCU community.
Thank you very much, Mark. That was a very kind introduction.
Dr. Levy, we know your involvement in HCU spans decades. Can you tell us more about those early years and what was evolving in the discovery of HCU and your involvement in that process?
Well, let me tell you, Mark, the telephone rang at the laboratory. I was into the beginning of my second year fellowship at the Mass General Hospital in the amino acid laboratory. And it was Dr. Robert McCready, who was director of the newborn screening program in Massachusetts. He said, is there anybody who can come over and look at a big spot that we have on a paper chromatogram? I welcomed the opportunity to go to the state laboratory, not only to see this spot, but because I wanted to see the state laboratory. I'd heard about newborn screening, and I'd heard about the state laboratory and the Massachusetts program, which was probably the best newborn screening program in the country at that time. I get up to the 3rd floor and introduce myself, and they say, "Oh, yeah, good, glad, thanks." And then they show me this chromatogram, and it has a big spot of what I almost immediately recognized as methionine. And I only knew one reason for an elevated methionine at that time, and that is homocystinuria. So I said, I think this child has homocystinuria. I called the physician, the pediatrician, and I said, can you have the family bring this little boy into the hospital? Monday morning, I go to the laboratory, and there is the little boy. His name is Sean. Mm-hmm. And I see Sean, and he looks like a perfectly normal newborn. Okay. So I got a blood test. We got a urine on him, and we set about analyzing that. I said, by the way, do you have any other children? And the mother said, oh, yes, we have a daughter who's 4 years of age. I said, well, would you please bring your daughter in when you bring Sean in a couple of days, and I'll see him. We have the results, and of course the results showed an elevation of very marked elevation of homocysteine, and the elevation of methionine that we knew he had from the newborn screen. So, of course, they both had homocystinuria. So I started treating the little boy, and I tried to treat the girl. Now, she was on a perfectly normal diet. She was eating a lot of protein. She loved meat and all that kind of thing. we get him onto a formula that didn't have as much. Well, there was only one formula that anybody knew at that time that actually had been discovered by Dr. Perry in Vancouver. That, and of course, restricting to an extent possible the amount of protein that he was taking into his diet. So he was never in good control, but nevertheless, he was in somewhat good control. And of course, the daughter was never in any kind of control of homocystinuria. I followed them for 40 years, 45 years.
That was the first newborn discovery.
First case, and it was the first newborn discovered case of homocystinuria in the United States by newborn screening, and is, I think, probably maybe the second or third case worldwide that had been discovered by newborn screening. So that started me on my journey.
Talk to me about what was going on around the medical community in terms of the discovery of HCU. There was some early work in Ireland. There was some work being done by Dr. Harvey Mudd. And was it really the connection of some of that early discovery and then your discovery of this result for Sean in the newborn screening?
Well, I had known of the early work. I'd known of the original publication of the original cases from Northern Ireland, and in conjunction with the laboratory in London, of the original cases that was identified. And I had known through my looking up the data that Dr. Harvey Mudd at the NIH had discovered the enzyme defect, that is, of cystathionine beta synthase, CBS enzyme, as the defective enzyme in homocystinuria. So I knew of those, and I knew of the work of Dr. McCusick at Johns Hopkins. Dr. McCusick was a medical geneticist who was really the leading medical geneticist, had the leading training program for medical genetics in the country at that time. And Dr. McCusick was very interested in Marfan syndrome. But he had wondered whether or not some of the patients with Marfan syndrome maybe had been misdiagnosed as having Marfan syndrome, but actually had homocystinuria. And there was a urine test that we were doing at that time to diagnose homocystinuria. It's called the cyanide nitroprusside test. So he applied that urine to the patients who he knew about, whose urines he was able to collect. And I believe he discovered out of about 65 patients, I think he discovered about 20 of them had actually homocystinuria, not Marfan syndrome.
And what year was this?
This was 1965. He published, he and his fellows actually, who did most of the work, actually published this in the Journal of the American Medical Association in 1965. So that was the first large-scale publication of homocystinuria. So I knew of that work. And of course, I had known of Dr. Perry's work in Vancouver, who had tried to use the soy-based formulas to switch off. So that's what I did, and that got me on. That's how got me on the road to homocystinuria. And this was a unique opportunity, really, to look at homocystinuria from the newborn period, to be able to maybe reduce whatever was the toxic agent in homocystinuria, which we all assumed was probably either methionine, because that was elevated, or homocysteine. Right. And we could not measure homocysteine specifically. That didn't come around until later. And so it was an opportunity to actually look at as best we could, but what you would be able to accomplish if you were to begin trying to reduce the amount of homocysteine and methionine in the blood of patients with homocystinuria from the newborn period,
right,
and therefore prevent the complications from occurring, because until that time, everybody who was diagnosed with homocystinuria already was complicated. That's how they got diagnosed. That's how they came to attention, because they had the problems of homocystinuria, and they were irreversible. Once you have dislocated lens, once you have developmental delay, once you have some of the skeletal features and so forth, that's not going to be changed necessarily. But again, we were limited in the types of treatment that we had, because we did not have a specific methionine eliminating formula, which we definitely needed and which we have today. And the low-protein foods were extremely limited and extremely difficult for people to adhere to.
Tell me more about, as you learned in those early days and discovered more of homocystinuria relative to B6 responsive patients, for example?
Well, at about the time that I came into the field of homocystinuria, there was some idea that there was already beginning to be known that the enzyme cysteine beta synthase, CBS enzymes effective in homocystinuria, required vitamin B6 as a cofactor to make it work. So in 1969, which is only 2 years after I came into the scene, Dr. George Spaeth and Dr. Barber came upon a patient who, when they gave vitamin B6 to with homocystinuria, when they gave vitamin B6 to, lowered almost completely into normal the amount of homocysteine methionine that patient had. Here was an opportunity to treat homocystinuria with something very simple, and that is to give me additional amounts of vitamin B6. And it turns out that is a very important discovery in homocystinuria, because it means that a certain subset of patients with homocystinuria do indeed respond to vitamin B6. So it's incomplete, but it's at least a treatment, and for some patients it's a very important treatment.
But that isn't where your journey ended. You continued to work to develop and understand homocystinuria. Tell me about the B12, your efforts to understand the interaction of B12 and where that led the broadening of the effects of homocystinuria across what we know today as other treatments associated with the disease.
Well, because I knew about homocystinuria, and because I was already aware of the fact that in homocystinuria you got two major metabolic findings. One was an elevation of homocysteine, the other was the elevation of methionine. Right. So a few years after this 1967 discovery of the newborn, I think about early 1970, 71, 72, there was a baby admitted to the Massachusetts General Hospital at 3 weeks of age with respiratory distress. And they couldn't figure out where it was coming from. So they sent a urine to the laboratory. I got it, and I looked at it, and others looked at the results. And sure enough, in the blood and the urine, by quantitative analysis on what we call the amino acid analyzer, which is a much better method of looking at these things than the paper chromatogram, there was this huge elevation of methionine, of homocysteine, and there was no detectable methionine. And I knew of Dr. Mudd and his work at the NIH. So I called, introduced myself, and I said, I'm puzzled. He says, give me some time, and I'll call you back. Let me think about it. Oh, I don't know, an hour later or something, I get the phone rings again. I pick it up, and it was Dr. Mudd, and he says, yeah, I've thought about it. He says, have you measured methylmalonic acid in the urine? And methylmalonic acid, I knew, because I knew that from newborn screening, was a different disease. Methylmalonic aciduria, we were screening for it. Right. We knew about it. Well, I did, and called him the next day, and I said, lo and behold, he's got this very large amount of methylmalonic acid. So here was homocysteine elevation, methylmalonic acid, but no methionine. And I'm still puzzled. He said the other reason is that vitamin B12 in the body does not act as vitamin B12. Vitamin B12 must be broken into two forms. And he says, it's been this vitamin B12 metabolic defects have been discovered in animals, but never in a human. And so one thing led to another. We did some further testing on the baby. He did some testing, and Dr. Eulendorf, that he was working with at NIH, did some further testing. And sure enough, it turns out this was the first human disease of vitamin B12 metabolic defect. And it turns out that this was what we now know is the cobalamin defects, or the methionine remethylation defects. And there are a number. This was the original case of cobalamin C, which is the most common of the cobalamin defects. So this expanded enormously our understanding of homocystinuria. It's not just one disease. I mean, homocystinuria can be a feature of many different diseases.
Interesting. So Dr. Levy and Dr. Mudd, really the pioneers in the discovery of the cobalamin,
Yep.
cobalamin C.
Yeah,
Amazing.
we were co-discoverers. Yep.
Amazing. One area that I know you were involved in, Dr. Levy, and I'm curious to hear your story, is the use of betaine. To treat HCU, it's every tool in the toolbox, if you will, and an important tool and an important discovery in treatment of HCU was betaine. Can you tell me about your early days and involvement of that, and how you saw that therapy evolve?
Yeah, this was fairly, again, early in the 1970s, maybe by mid-1970. I get a call one day from Dr. Stan Berlow in Wisconsin. I did not know Dr. Berlow. I knew of Dr. Berlow because he'd published a couple of papers on homocystinuria, but I did not know him. And he said, can you come to Wisconsin and along with another person here, I don't remember who it was, and myself and a biochemist friend of mine who has discovered betaine as a possible treatment of homocystinuria. So I go to Wisconsin. We met one day and with about 4 or 5 of us, and I'm learning for the first time about betaine and what this is. And it's a form of remethylating methionine, or it's stimulating the remethylation of methionine to reduce the homocysteine, because homocysteine then goes back to methionine. Methionine goes to homocysteine. It's a cycle. If you can enhance the remethylation, if you can enhance the ability of homocysteine to go back to methionine, you can reduce the homocysteine. That was the whole idea. And so this was a compound that I learned called betaine. And so the idea was, how do we get betaine into the patients with homocystinuria? Well, choline is the precursor of betaine, and choline was readily available. So you say, okay, let's give a lot of choline, and they'll make betaine, and that didn't work very well. And so eventually, betaine was produced as a product.
So even before it was wasn't even broadly available, there was this discovery of yet another tool, another part of the therapy, and you were involved in that. You were involved in understanding that and then evolving that to the point where it became broadly available to patients.
Well, we began advocating for it, and eventually it was produced as a product and available, of course, in the market we know today. Yeah.
What I'd ultimately like to talk about is, what are we seeing today for, these potential game-changing therapeutics? But talk to me about the sort of evolution of therapy, from those early days to now.
Well, it's interesting from my standpoint, to having lived long enough to have seen it from the very earliest days when we had almost no treatment for homocystinuria, as I've mentioned, to today when we're talking about some non-dietary treatments that are very important. It's a sea change in terms of our ability to treat homocystinuria. So it's evolved from the early days of the soy formulas to an elemental formula, which was based on the PKU elemental formula. It was just a simple matter in the PKU formula, the elemental formula, taking phenylalanine out and allowing everything else to be put in. And then you just change it by taking everything else with methionine.
Yeah.
I mean, you take methionine out and you put everything else in. So instead of having a low phenylalanine formula, as you do, or no phenylalanine formula, as we do with PKU, you have a no methionine formula for homocystinuria, and that's made a huge amount of difference in terms of the ability to get a certain amount of elemental protein, in a sense, into the diet, and yet not have methionine as part of it. And that allows additional foods to be eaten in the low protein form of the diet. Right. But in addition to that, you've got low protein foods that have been manufactured by Cambrook and therefore have added to the nutrition that they get in terms of their low protein. And now we're talking about non-dietary forms of treatment. Right. And of course, that gets us into things like enzyme replacement therapy, which is still in clinical trial. It's called pegtibatinase, which looks promising, and we hope it will be promising in terms of reducing the amount of homocysteine. And then, of course, we keep talking about gene therapy, or gene editing, either one of those, which is we're talking about for all metabolic disease, but including homocystinuria, and that could become a reality one of these days. We hope it would become a reality. So there's some very exciting things on the horizon for treatment of homocystinuria.
Dr. Levy, your early discovery of Sean and understanding the potential for identifying homocystinuria through newborn screening, it didn't end there, right? You've evolved that approach and that methodology to ultimately capture those patients' early days of life. Can you tell me about how that's evolved, and you're really you're pioneering of it, but also you're pushing and maturing that incredibly important need to capture these patients early. Can you just explain that some more to us?
Well, it was really the discovery of this original case of newborn screened homocystinuria that got me into newborn screening. Because, as I pointed out, I didn't know where the newborn screening laboratory was, but I knew about newborn screening. I certainly knew about newborn screening for PKU at that time. And I was very interested in newborn screening because I saw newborn screening as a method not only of preventing the consequences of metabolic disease, which is, of course, the most important thing about newborn screening, but also a method of research in terms of looking at different ways in which we could prevent the problems beyond just the screen itself, but able to new treatments and things like that of patients who were identified newborn screening. So I was very interested in newborn screening. And of course, going over to the laboratory and being introduced to newborn screening was a very, very major point of my professional life. So I became a vital part of the newborn metabolic part of the newborn screening process in Massachusetts. Well, after about a year or so of going to the laboratory, because at that point I was going to the laboratory about once a week to look at things and to be told or to discover that there were babies who were being identified with either PKU or some other newborn screened metabolic disease. And one day, Dr. McCready, again, the director of newborn screening, said, Harvey, he said, there's a meeting in Buffalo with Dr. Guthrie, who I'd heard about, and of course he was famous. And so I went to Buffalo and I met with Dr. Guthrie and about 5 other people, who I was meeting for the first time, and we were talking about PKU in that meeting. And so I became kind of an arm of the Guthrie group as the physician who actually saw patients as well as became involved in other kinds of activities that involved newborn screening. And I was probably unique in the country at that time because I don't think there was another physician who actually was in a newborn screening laboratory and actually saw patients. And but that introduced me to Dr. Guthrie, and of course he was a marvelous person and a marvelous collaborator of mine. I mean, he was the king, and in newborn screening, of course, and that got me involved in newborn screening activities throughout the world. There were many meetings in Germany and Austria and Poland and many other places in which I met people from all over the world. It got me very involved in newborn screening, which was certainly homocystinuria was a very vital part of it.
And of course, HCU Network America is a big advocate of improving newborn screening, and you being a medical advisor to us and to the network, we continue to pursue more accurate, sensitive screening and more common screening. It's not available everywhere, right? So,
and HCU American Network, as well as the Australian network, is so important for families with homocystinuria because it brings families together. And before these networks began, there was no way families were isolated. They said, well, I don't know of anybody with homocystinuria. We're the only family in our area. Sure. That was true throughout the country. On
emotional, medical, right? Because you're in those isolated conditions, you're really up to your doctor who's treating you, who she or she may not really be fully aware of perhaps the treatments. And so indeed, yeah, networking and community is huge.
So you bring information about homocystinuria to the families, and the families bring information about themselves to share with other families. It's extremely important. And it's very important for professionals, for us, because it means that many families come together for us, and we can begin to involve those families in new studies of homocystinuria, which may improve the treatment and outcome of homocystinuria enormously.
What advice do you have for the patient, or more likely the caregiver of those patients, or the people within that patient's network that are working through the treatment of HCU?
Well, the first thing I think we emphasize, Mark, is to control the homocysteine as best you can. That's very important. If it's a baby and a small infant, then you want to control that homocysteine almost, if not to a normal level. The upper limit homocysteine level is about 15, and so you want to get that level down to as close to 15 as you possibly can. And you want to keep it through the infancy period and through the newborn period, let's say close to that. If it's not 15, it'll be 20 or 25, something of that nature, which we think is quite safe. As they get older, we recognize that it's inevitable that the homocysteine level is going to go up. Right. And we want to keep it as maybe close to 80 as we can. That's our feeling in Boston. But certainly below 100 and somewhere in that neighborhood. So you have to take the formula along with the low-protein diet. Those are absolute certainties. And so if you take the two together, you're going to get enough nutrition in the low-protein and low-methionine formula, as well as as whatever you're taking in the low-protein diet. And then your betaine, of course, adds to that tremendously.
So, Dr. Levy, we've heard from the early days to now and everything in between. You've been a force in the discovery of HCU, in the treatment of HCU, and to us as family and caregivers, you're a beacon of light. But when you look back at your many years of progress and influence, tell me how you feel about, and how you want to be felt about your contributions and critical contributions to this community and those not just with the homocystinurias, but really the metabolics in general.
Well, Mark, I would hope that I would be remembered as a person who really did some work and made some progress in terms of understanding homocystinuria a little bit better, both in terms of its newborn screening consequences, in terms of perhaps the dietary and non-dietary new therapies for homocystinuria, but also in terms of expanding with Dr. Mudd, expanding the concept of homocystinuria, so that instead of homocystinuria as a disease, homocystinuria becomes a finding in quite a number of diseases. That's something we never even thought of in the early days of homocystinuria. It was a one disease, and now we know that homocystinuria is simply something that occurs as a result of a number of different disorders. And so I would hope that in addition to whatever impact I've had in the field of HCU, classical homocystinuria, would be an understanding of the more expansive idea of homocystinuria and the many different diseases that do include homocystinuria.
Dr. Levy, it's been absolutely amazing sitting here and talking with you, hearing your story and hearing what you've been able to accomplish over these 5+ decades of dedicated service, the discovery, the treatments, to us as an HCU community, to us that are challenged by HCU. It's an absolute honor to hear your story and really appreciate all that you've been able to accomplish in support of us as a community and for those challenged by HCU.
Thank you very much, Bart.
So on behalf of the HCU community, globally, I just want to thank you for all that you've done for us to improve the well-being of those challenged by HCU, to improve those that care for those challenged by HCU. Dr. Levy, I truly thank you for your time today, and I really appreciate deeply, what you've been able to do for us and for those in the HCU community. I was brought into the HCU community almost 33 years ago when my son Benjamin was diagnosed through the newborn screening program in the state of Massachusetts. And as I understand it, Dr. Levy, it was you who saw his dot on his card, and it was you that rang up his pediatrician to really call out Ben because he was borderline. And as I understand, there was some suspicion in all your experience that called you to that diagnosis, or at least that signal that we got during his newborn screening. And so from there, we were brought into Dr. Miriam Pola in the floating hospital, who then, through your initial diagnosis, set us on a course. We were indoctrinated into the HCU family, and from there, we were able to get Ben the treatment he needed as quick as we could allow. So personally, I thank you for your intuition, your experience, and your ability to see that edge or curiosity on that one patient that really set us in a much different outcome than perhaps we would have had otherwise. I was able to meet you in person some 3 years later after my son's diagnosis, when my wife Karen and some passionate parents formed the New England PKU Connection and Allied Disorder. And through that interaction and for the 33 years since, 30 years since, you've been a beacon of light to me personally and to my family, in what you've been able to do, your genuineness, certainly, but your ability to really guide and affect, the outcome for my children, but for many others within the community. I really appreciate personally all that you've done for my family and for the community as a whole.
Thank you.